Let's explore pressure a little bit here. Pressure is force divided by area. If you're dealing with calculus, then pressure is not necessarily constant throughout an entire surface, and so you'd have to get into the change in force over the change in area. If you look at units, the SI units of pressure would be the SI units of force over the SI units of area, which is the Newton per square meter, which physicists found too much to write, so they came up with Pascal, honoring, in case you're wondering, Pascal. So if I put a 3 kilogram block, we'll make it 4 meter by 4 meter by 4 meter, sitting on the ground, the pressure the block exerts on the ground, well, the force that it exerts on the ground would be a normal force. So if I imagine a force diagram here and I have a block sitting on it, I have weight acting down on the block and I have normal force acting up, and then I have normal force acting down and weight acting up. This is the force right here that is exerting pressure on the ground. And if the block is in equilibrium, the normal force and the weight are equal to each other. So the force would be the weight of the block divided by the area, which is just going to be the product of the two dimensions that are touching the ground. And I made it a cube to make the math easier. So the 3 kilograms times 9.8 meters per second squared gives me the weight of the block divided by the area of the surface touching the ground, and I end up with 1.84 pascals. A little bit potentially more interesting version of it is, suppose I have a bunch of steel nails, and I wrote steel in there, just some particular metal, I'm not talking fingernails. Can I stand on without puncturing my foot? And it depends on the bluntness of the nail. So I went ahead and made that the area of the nail, and then I pulled out a vernier caliper and I measured the diameter of it, and I had 1.2 millimeters. And so the radius is 0.6 millimeters, which leads to an area using the formula pi r squared of 1.103097 times 10 to the negative 6 square meters. Now, I had to look this up. I have not tested this out, but the stin typically punctures at 100 psi, that's pounds per square inch. And so I did a conversion here into pascals. And so if I'm standing on the nails, the amount of force that I will exert on the nails through my normal force, and again, I'm assuming I'm standing in equilibrium, should be equal to my weight. My mass is about 100 kilograms, and so the weight is about 980 newtons. The minimum area needed, where I'm still not punctured, is so close to, so the maximum area in order to puncture, I basically set them equal to each other. I set that as my target, and so that's my force divided by the area, and I end up with that is the area. So as long as my force is distributed over something larger than that, I will not be punctured. So converting it to number of nails, and I have converting quotation marks, so it's not a real conversion, but I take the area that I need to withstand it, the minimum area to withstand it, divided by the area of a nail, and I end up with the number of nails. And so I made a comment here about that's why lying on the bed of nails is preferred to standing on a bed of nails. Imagine the size of your feet and putting that number of nails close enough together to be able to stand on it. And it's not particularly easy. It's much easier to spread that number of nails over a larger area. And so from a practical point of view, lying on a bed of nails allows greater distancing between the nails when you're doing that. Anyway, there it is. A fun look at pressure.